Well, I want to say that I looked up my horoscope today and it said avoid having any pictures of you taken this week. For many cameras are really cameras, but there's one out there, just one, that shoots a tiny arrow into your head. The arrow will do nothing but make you think you're hearing reruns of Full House in your brain. Hopefully the culprit will be apprehended. Well, good afternoon. My name's Kate Wilson. I am a staff engineer at the Rhode Island Department of Transportation. And today I want to talk to you about a project that I've been involved in the last few years. But before I do that, I wish to thank the people who have made this possible for me to study Route 165. And that happens to be Colin Franco, Mike Sock, Corey Boba, and Dr. Deborah Rosen. Basically, I did go after a $42,000 grant so that I could buy equipment to study what's going on with Route 165. And I also want to thank Professor Lee, who has been my academic advisor since 1993. He's seen me through my bachelor's, my master's, and hopefully my PhD without him going any grayer. Well, it's just the point, running out of time, and basically we're getting this thing done. And I also am fortunately enough with that 42 grand to hire Amir Hassan, who's a graduate student, to help me collect the data. Basically, the evaluation of pavement rehabilitation strategies and intersection of performing systems. This is a research project to use state-of-the-art practice tool, which is AstroWare ME, a tool for design and analysis of new and rehabilitation of pavement structures, using regional calibration factors to predict pavement distresses and smoothness. What we want to remember about regional calibration, that each state has different soils, weather, traffic conditions. Our soil is different from Texas, Mass, New Hampshire, or Vermont. And basically, this research project is only for Rhode Island, because we're only using the parameters that we collect. The project. Route 165 was originally going to be reclaimed, but one of the things that we were going to do was we were going to use it as a test section. We were going to use 5 different modes of materials in the reclamation, and we were also going to use 2 control sections. We were using calcium chloride, emulsion, Portland cement, and a geogrid. And then we used a control which had absolutely no additives. And then we're also using Route 138, which was done in 2009, which we reclamated between Route 112 and Beaver River Road with calcium chloride. Route 165 has high moisture. Route 138 has low frost heaves. And since 2009, we haven't had any rutting. What I want to also say that Route 165 was an in-house project done by state engineer. And I also did Route 138 as an in-house project. Route 165, 7 miles long. It was estimated to be about $8 million, and it came in about $8 million. We did put in about $200,000 in safety items. We used a warm mix asphalt. We added WIM sensors, and then we also added the different reclamation additives. We also used a 19 millimeter base course with a 12.5 millimeter hot mix asphalt with pay factors. This is a picture of Route 165 before it was reclamated. So why did we select Route 165? Well, Route 165 consists of a high water table from November to May and from September to June in different sections. From the Rhode Island Soil Survey, the subbase is consisting of sand, fine loam, and gravel. Basically, it's a susceptible of moderate to severe frost action and severe wetness. With this, the roadway has absolutely no liquid limit or plastic limit, so there's absolutely no fines. This road was reclamated in 1986 using calcium chloride, and when this was reclamated, there was actually peat that was found and had to be removed. Route 165 has high truck traffic with heavy truck loads. It is, there has no major intersections or traffic signals. Basically, if a truck goes from the Connecticut state line to Route 3, it's usually a very direct route. So the speeds on this road are consistent and they don't fluctuate that much. So basically, damage caused on this road will be from humans and environmental conditions. Before we reclamated, we basically were getting very many customer service logs on how bad the pavement condition was. And this was also a reason why this was put in the tip and that we started work on it. Reclamation projects we found usually consist about $2 million per mile. And on Route 138, which was 2 miles, was also about 2 million, while Route 165, 8 million. Moisture damage in the subbase. Route 165 is a rural connector road. It has a complete drainage system, combination drains and pipes, manholes, catch basins, 10,000 linear feet of pipe. And basically, what we wanted to do was use this so that we could use this so that when we look at another road, we can use this as a comparison, because we have been finding similar damage on Route 165 versus on different ones on Route 102, West Main Road, East Main Road, and so basically we're hoping that the research from this project will help other projects. This is a detail that went into our contract book for WIM, basically Weigh in Motion. What we did was we installed a new cabinet, we upgraded the computer, we went wireless so that we can get instant access to the information anytime we need it. WIM data is very important to this project because we need to use this data to capture and record axle weight, gross vehicle weight, and the WIM data will uses our AASHTO ME will use the WIM data for the heavy truck traffic as an input. And then the difference between the old 1993 pavement design guide is that AASHTO only uses heavy truck traffic, while the 1993 design guide used everything from cars to vans to trucks. One of the most important things that we need about the WIM is that we will be able to track on how much percentage growth that we get on these highways, especially Route 165, because when we put in the inputs, we need to make sure that we don't overestimate or we don't underestimate so that we can get a very good prediction. Again, movement of moisture. Route 165 does have a very high water table, especially in the fall and in the springtime. Here is the construction, and this happens to be where we were installing a geogrid. One of the things that we did on Route 165 is all the specifications for each individual reclamation. We try to make sure that we had 8-inch reclamated, and then we put in the additives. And we also wanted to make very sure they were reclaimed at the same way and the same depth. But with the geogrid, what we did use was a special graded hydraulic stone to aid in the drainage. This is a picture of what happened I think it was the spring of 2014. Basically, water was coming up off the pavement like a fountain. The contractor went and called the resident engineer, and they decided to open up the road. And when they did, this entire section flooded. Basically, this type of a problem was causing large ice spots in the spring and the fall in our travel lane, which was causing accidents. What we did to correct this situation was we added a perforated pipe, and then we created a new outfall so that when the water table did rise, it would go into the shoulder and into the drainage ditch. So what are the effects of the high moisture content? Well, basically can reduce the pavement life 16 to 45%, which can take years off the design life. And if a pavement has 20 years, basically we would have to have repairs done sooner, and these repairs are definitely adding up. And right now, something that we're having a hard time to afford. One of the things that we always looked at is the structural adequacy index. Basically, when a project is done, we can start shows how a pavement can deteriorate over time. Basically, when a pavement is rehabbed, we don't go up to 5. It's something around 4.8, 4.5, and basically we monitor until a pavement can go down to 2 to 1.8. When a structural index goes to about 2.5, that's when we feel that we need to do some rehabilitations so that we can get more life out of the pavement. But hopefully the research that we do, we can predict when that 2.5 rank is hit so that we can prepare and make sure that there's adequate funding for any type of repair. One of the things that we have been doing is an International Roughness Index, IRI. Basically, we've determined that less than 95 is good. 95 to 170 is fair, and poor is over 170. Basically, now the state is doing IRIs consistently to eliminate so that we can determine the pavement conditions. And IRI can be converted to structural adequacy index so that we can keep monitoring. And then the outputs, Ashtaware ME software can predict IRI in layers, properties, damage, and key distresses. This is an IRI that was just recently done, and if you notice, most all the data is less than 95, which is good. And this was done 1 year after construction was completed. And basically the comparison between the IRI and the ME Ashtaware will be between the field performance and the predicted. And we basically can start adjusting the ME program so that we can have a better performance system. Right now, one of the projects that we are doing this month is collecting the data for this project. Basically, we did hire, went out and had Aaron Baxter. We took samples before the pavement was paved, the sub-base was paved, and basically we tested it so that we could get properties of the subgrade soils, sub-base materials, base materials, and asphalt surface on those 5 test sections. We are collecting data for the falling weight, IRI, GPR, and we're doing a comparative analysis. We're also collecting temperature data, weather data, and basically Route 165 has 2 monitoring wells that are close by that we're going to be getting our water table from. So basically we are developing this month a baseline so that we can continue. We have been doing falling weight deflectometer tests on Route 138 since 2009, and we have about 3 falling weight deflectometer tests done on Route 165. And hopefully we'll have one done before the end of the month. And after we gather the data, we're going to evaluate it, we're going to analyze, and then we're going to come up with a comparative analysis and then give a report to RIDOT. Some of the equipment that we'll be using happens to be the Weigh in Motion, the WIM, a falling weight deflectometer, an IRI, and a ground penetrating radar. One of the most important things that we used was the resident engineer. And I want to thank Bert Roberts. He was out there every single solitary day making sure that the contractor laid the asphalt and it was conformal throughout the whole project. And when we did a ground penetrating radar, the pavement was exactly to where it was specified. One of the things we're going to be using is the falling weight deflectometer. We heard about different things that went on this morning, and basically it's a device to measure pavement deflections in response to stationary dynamic loads. Basically, we want to simulate the passing wheel load, and so it can evaluate the structural capacity. Basically, the FWD will use back calculation and deflection basins of the wheel load so that we can determine what the stiffness is of the pavement and of the subbase. Basically, this is a picture of two different pictures of Route 1. One is West Greenwich, one is in Exeter. Basically, we're using the equipment. The IRI doesn't give moduli, but the falling weight determines how much a subbase can be weakened when there are freeze-thaw seasons and during major storms. And hopefully we will be getting falling weight every about 3 to 4 times a year. Take the average and therefore make sure that the Ashtaware ME is exactly where it should be for performance. Oh, no, I got 2 more slides. No, there's no stress here. All right, so basically because we have the equipment, the falling weight, the IRI, the GPR, the Ashtaware, so basically in situ data, we will be able to compare and predict the performance conditions, and so that we'll be able to get a good final product. Here's some just close-ups of what Route 165 looked like. Basically with the moisture problems, basically water was coming up, washing out the fines, which then caused rutting and potholes in the travel lane. I did manage to get a hold of a skid testing 2006. Basically this is under 50 usually, and that usually means that we do need some work to be done. And if you notice the lower points, those kind of correlate where we have hills, where we have the valleys where the pavement was in the worst. And of course now here's a picture of Route 165 completely rehabilitated.
Okay.
A few 2 minutes.
All right.
A few other things that we did. We used a 2.5-inch base 9mm hot mix asphalt. We used 2 inches of a 2.5 hot mix with pay factors. We gave the contractor the capabilities using as much wrap as he wanted in the 19mm, and basically wrap is old pavement used from micromilling and R&D. Basically, if you ever drive near the maintenance building, you can see Carty has one big wrap pile. So, in conclusion, there's one more. Basically, we want to use the collected data to compare and to predict the values and to predict the payment performance. I want to thank you all for coming here. And next year, hopefully, we'll have more technical data and I'll be able to get my PhD. So, thank you very much.